Okay, we're back, and this is a mechanics one. This is just a short video on buoyancy and how to find buoyant forces, and more specifically, what does it take for something to sink or rise if you submerge it in a fluid, or just stay put in some cases? What's actually the physical reasons why that happens? This goes back a ways to Archimedes. You might know the story. He had to figure out if a crown was pure gold or not for the king. And he was stumped. And so one night he had a pretty full tub of water, and he got in there to take a bath, and he noticed all the water that got displaced and went over the top of the tub. And that was his eureka moment. And he figured out that buoyancy, the so-called buoyant force, that is the upward push that a fluid puts on an object, is equal to the weight of the fluid displaced by the object. When you place it within the fluid. So here's a little picture. If you were to take an object and submerge it entirely, and it could be water, it could be any kind of fluid, it doesn't really matter. Now you might remember from chemistry that if you want to figure out and find the volume of an object, you place it in water, and the volume, the volume of water that's displaced by the object is the volume of the object. So these two volumes are going to be the same if you completely submerge the thing inside the fluid. And your force diagram is just gravity trying to pull the thing down and this buoyant force trying to push up on it. Okay, so the object has its own density, that's the rho that you see in the diagram, and the fluid has its own density. And Newton's second law is pretty straightforward. F equals ma just means that you have the buoyant force up and the gravity going down, so we subtract those. Now, the buoyant force is equal to, according to Archimedes, the weight of the displaced fluid. Okay, well, weight is gravity, so we need the mass of the fluid multiplied by the acceleration of gravity. But the mass of the displaced fluid is just its density multiplied by the volume. Okay, in this case it would be the volume of the object. Okay, so if we substitute these things back into Newton's second law, we have F equals ma. Here's the weight of the displaced fluid. Here's the weight of the object. Okay, its density times volume is its mass. And we can simplify that to the acceleration of gravity times the volume of the object times the difference in the densities of the object and the fluid. So the key is density. So you probably have heard this before. You know, if you place something in water, if it's denser than water, it sinks. If it's less dense, it floats. Well, here's kind of the proof of that. Here's why that's true. That's in order to get the buoyant force either greater than the weight of the object, or if the weight of the object is greater than the buoyant force, it's going to sink. So here's the three conditions that you can get from this. To get something if you submerge it and then make it rise, the density of the fluid has to be greater than the object's. If you want it to sink, you need the density of the object to be greater than the fluid's. And if you submerge it, let go of it, and it just stays there, that means your forces are equal, and it means the densities of your objects are equal to each other. Okay? So, yeah, it's just kind of a neat little thing. There's not much more to it in the simplest case. I just wanted to give a brief description of what the buoyant force is and why things sink or float. Okay? So I hope that helps, and until next time, we'll see you later.